Hi, Algebra 2 Honor students. Today is going to be Unit 11, Day 1. Today we're going to be taking a look at some exponent rules. So today I think will mainly be a review of things that we've seen in the past. So we've done exponents just a little bit, thinking back to our radicals unit in the beginning of the year. And this is something that even going back to the summer homework assignment, you would have seen some of the basic exponent rules. But to get started in this unit, let's just make sure we're really confident with some of the rules, such as this first one right here. So if you have x to the a times x to the b, if you're multiplying two things that have the same base, you add their exponents. Actually, sorry, I better fix that real quick. Should be x to the a plus b power. All right, so we'll do some practice with these exponent rules in just a moment, but when you're multiplying two things with the same base, we add the exponents together. All right, moving on to number 2. If you are dividing two things with the same base, x to the a divided by x to the b, we are left with x to the a minus b power. So keep the base and then subtract the exponents there. Taking a look at number 3, if you have x to the a and then everything to the b power there, the rule when you raise a power to another power is you can write that as x to the a times b. So power to a power, the rule is you multiply those exponents. If you have anything to the 0 power, the result there is 1. When you have negative exponents, we typically will never, in simplest form, leave negative exponents as part of our answer. I won't say never, but I'll say most standards in math is that we don't leave negative exponents as a part of our final answer. So if you have x to the negative a, that's the same thing as 1 over x to the a power. And then I have 2 more for you here. Number 6 is if you have a fraction to a power, as long as it's a monomial and a monomial, you can raise the top to that power and the bottom to that power. So that would be x to the a over y to the a. And the last of our rules here is one that we saw back in our radicals unit. It's that if you have a fractional exponent like m over n, that can be written in radical form as the nth root of x to the m power. So just kind of recalling some of those old exponent rules from back in the day. Hopefully those all sounded familiar to you. And now what we're going to do is, like promised, put them to practice. So if we take a look at some practice questions here, let's start with something like 3x squared y cubed squared times 4x to the 5th y to the 7th. So to multiply these together, the first thing that you have to think about is before I multiply, I have to resolve the exponent on the outside here, right? We want to follow PEMDAS. So when I square this first, it's really a monomial, right? These terms, there's no separation of addition or subtraction. So you can square everything on the inside. 3 squared is 9, x squared is x to the 4th, y cubed squared is y to the 6th. Okay, so we're multiplying the exponents when you do a power to a power. When I multiply that by 4x to the 5th, y to the 7th, now we're going to apply a different rule where coefficients out front get multiplied. So that's going to be a 36. But x to the 4th times x to the 5th is going to be x to the 9th. So the rule for multiplying two things with the same base, add those exponents. Similarly, you would get y to the 13th. And then that's the final answer for number 1. All right, moving on to the second example here. If I had 27 a cubed b to the 4th c to the 10th over 54 a squared b to the 7th and then c to the 8th. If I said let's simplify this and express all exponents as positive exponents, in the end, 27 over 54, we can reduce that at least to 1/2. So you can start by doing a little bit of reducing. A cubed over a squared is a to the 1st. B to the 4th divided by b to the 7th. Remember, the rule here is that I'm actually subtracting those exponents. So that's b to the negative 3rd, technically. And then c to the 10th over c to the 8th is c squared when you subtract the exponents. So in the end, if I want to write this with all positive exponents, what we'll see is that anything that has a positive exponent currently is going to go to the numerator and be attached to that 1. B to the negative 3rd, remember, is the same thing as 1 over b cubed. So we can write this as b to the positive third if I attach it to the 2 on the bottom. The final answer, when simplified, I would expect to see for number 2 is a times c squared up on the top, and then the 2 times b to the positive third on the bottom. And if you look back to the original, I think a lot of you might have thought of this as simplifying by saying, all right, b to the 4th goes into b to the 7th, but we still have b cubed in the denominator left over. So if you don't like that step of writing that negative exponent, that's kind of a justification as to why negative exponents become positive when they get moved to the denominator, right? So if you have more b's on the bottom, you should really still be left with some b's downstairs then in the denominator. All right, so that's a quick note about number 2. Number 3, let's do a fraction 5x squared over 3y cubed to the negative 2nd power. So in order to simplify a fraction to a negative power like this, I'm going to highly recommend you do a quick fix in the beginning of the process. And although I didn't write this as an official rule, if you look back to rule number 6 from earlier, which was x over y to the a is x to the a over y to the a, if you have x over y to the negative a, instead of doing x to the negative a and y to the negative a, you can change this by flipping the fraction and making that positive. So this is now the same thing as y to the a and x to the a. It's going to make your life, I think, a little bit easier, as opposed to maybe introducing a complex fraction there. So for number 3, what I'm going to do is I'm going to flip that fraction over first, make 3y cubed on top and 5x squared on the bottom, and then change that to the positive 2nd power. Okay. Now that I have that established, I can square the top, so that's going to be 9y to the 6th. The bottom is 25, and that's going to be x to the 4th. And that's really as far as we can go for that one. Okay, there's no variables to cancel. 9/25 is not a fraction I can reduce any further. So that would be the final answer for number 3. Okay, last one that I'll do for now, and then we're actually going to move to the packet and do some practice questions in there. If we had a to the 5th, b squared, c to the negative 7th, and on the bottom I'll put a to the negative 3rd, b to the 4th, and then c to the 12th. Okay. If I want to simplify here, one thing I'll suggest is that whenever you see negative exponents, we think about, all right, we want to make them into positive exponents. But what might happen is if you are dividing and you subtract top minus the bottom there, notice how that's going to turn into a positive exponent here, right? So for the first term, when I divide the a's, 5 minus negative 3 is actually a to the 8th. So that kind of resolved itself already. Now, we're still going to have an issue with the b's because when I subtract 2 minus 4, top minus bottom, that's negative 2 as an exponent. And then negative 7 minus 12 on the bottom is now negative 19. So we still have 2 terms with negative exponents. And the last step, we're going to make those into positive exponents by moving them to the denominator. B squared and c to the 19th would go in the denominator and become positive. We'll leave a to the 8th up in the numerator. Okay. And by the way, for that reason, when you have a negative exponent, and if it's in the bottom, you can make it positive by moving it up to the numerator. So if you have 1 over x to the negative 5th power, let's say, that's equivalent to, if I move it to the top, x to the 5th. So if you want to make an exponent positive within a fraction, you are allowed to move it to the other part. And I guess the reason why is I would write it like this first, right? X to the negative 5th is 1 over x to the 5th. If you multiply the top and bottom by the LCD, which is x to the 5th, you wind up getting x to the 5th over 1 on the bottom, which is what I wrote over here. So there's the quick algebraic justification why, but I would almost kind of use this as a general rule and just move it to the numerator to make it into a positive exponent. Okay. More often, we're taking negative exponents and moving them to the denominator. But if it already is in the denominator, you're allowed to move it to the top. Okay. Let's go ahead and take a look at the packet. There's some good mixed practice that I'm going to do with you here for exponent review on page 1 of the packet. So if you hadn't opened that up, I'm going to go right to the negative exponent section and just do a little bit more practice here just to make sure we're okay with simplifying with negative exponents. If you have -6 to the -2nd power, that's the same as 1 over -6 to the +2nd power. Right? Make it into a positive exponent, and -6 squared is 36. So the answer number 1 is 36. Okay. If I come across here number 3, 2 times 1/2 to the -4th power. Well, if this was a positive exponent, what would I have to do to the 1/2? Make it 2 over 1. So we did that kind of trick earlier in number 3. If you have a fraction to a negative, flip the fraction on the inside and then make it a positive exponent. Well, 2 over 1 is just 2, right? So 2 times 2 to the 4th, that's 2 times 16, which is 32. And the nice thing about all of these is that you can check them on the calculator, but look how fast I can do them without. Ready? 2/3 to the -3rd, that's 3/2 to the 3rd. Flip it, make it positive. 3 cubed is 27, 2 cubed is 8. Final answer is 27/8. So hopefully once you get used to negative exponents, you're pretty confident to evaluate with them. As a reminder, we just talked about a to the m over n power is the nth root of a to the m. I believe we did that as a caret back in the day, right? The bottom is the root of the caret. The top gets the power from the sun. So these are just quickly rewriting in radical form. If you have x to the 1/2, it's the square root of x to the 1st. When the bottom's a 2, we don't usually write the 2 as the root because the symbol here implies it's a square root. But for the middle, it would be like the 5th root of x cubed, something like that. If it's already in radical form and we want to use a fractional exponent, the 2nd root, which I just said it's usually not there, but I'm giving it to you for this one. The 2nd root of x to the 5th would be x to the 5/2 power. So this is the root that goes on the bottom, power goes on the top. This is the same thing as 1 over y to the 7/3 power. Okay, so just a little bit of practice with converting back and forth between fractional exponents and radical form. And I think that really helps to do some of the evaluating on the last page here. So the last thing I'm going to do is just some of these practice questions. I'll jump around and try and get to a wide variety here. If I go across the top row, 4 to the 5/2 power without a calculator, remember this is the root and this is the power, it's the square root of 4 to the 5th. And I'm going to always recommend taking the root first to make the number smaller and then raise it to the power on the inside. Because the square root of 4 is 2. So this would turn into 2 to the 5th, which is 32. Double check it on the calculator. It should come out to check to that answer. 8 to the 2/3 power. Let's see how fast we can do this one. It's going to be the cube root of 8 squared when I write it in radical form. So the cube root of 8 is 2. And then I'm going to take that 2 and square it. 2 squared is 4. Okay. If you look at the next example, I would treat this as the same thing as the last one with that negative out front. Okay, so it's the negative cube root of 8 squared. So I want you to be a little bit careful there because notice how in number 4, the parentheses are around the -8. So that's going to make things a little bit different. But when there's no parentheses around the -8, you're negating this part first. Think of it as PEMDAS. Do exponents before you multiply by -1. Well, since we already know the cube root of 8 squared is 4, we're just going to negate that answer to make this -4. Okay, but if we see how that changes a little bit for here, -8 to the 2/3, this would be the cube root of the quantity -8 squared. So notice how the negative kind of travels on the inside here. Now, I know you might be getting a little nervous because we have a radical sign with a negative on the inside, but have no fear because you can take the cube root of a negative number. A negative times itself 3 times is still negative. So the cube root of -8 is -2, and that's what we're going to square. Parentheses here really do matter. The parentheses around the -2, when I square it, turns into a 4. And just kind of for the sake of double checking some of these things, let's just check the last two because they look almost identical, but notice how they have different answers. So if I were to do -8 raised to the 2/3 power, that gives me the answer of -4. But if I put parentheses around the -8 and then raise that to the 2/3 power, that's my answer of +4. So hopefully you can see the justification based on the breakdown of those radicals. But certainly if you're unsure about some of these, when there's numerical values involved, we can definitely double check on the calculator. All right, Moving down to the bottom section here, let's do number 8, 1/25 to the -3/2. If you don't like the negative power with the fraction, flip it over. So 25/1 to the +3/2. Okay. Don't flip the exponent, okay? So that's kind of a common mistake. It's flipping the inside part here. So that's just 25 to the 3/2 power, which is the square root of 25 cubed. I have no idea what 25 cubed is, but like I said, I always use the root part first. Take the square root of 25, that's 5. And then 5 cubed is a little bit easier for me to rationalize. That's 125. If you need a calculator to help you out with that, go for it. Okay. And then towards the end, you'll kind of just see some combination problems here. So like 9 to the 3/2 minus 3 times 5 to the 0. Let's do this part first. It's going to be the square root of 9 cubed. And at the end, it's minus 3 times 5 to the 0. Make sure you do PEMDAS first. 5 to the 0 is 1. So that's going to get multiplied by this 3 eventually. What is the square root of 9? The square root of 9 is 3. So we get 3 cubed minus 3 times 1, which is 3. Well, 27 minus 3 is a final answer here of 24. Okay. Last one I want you to try. I'm going to give you the challenger. Try this one. And I'm going to go over right now. But I want to see if you hit pause right now, if you can get the same answer that I do after doing some simplifying. Okay, so for this last one here, if you've hit pause and now you're coming back to me, it's going to be the square root of 16 cubed. That's the first part. Minus 2 to the -2nd. I'm going to make that 1/2 squared. Plus 5 times 4 to the 1/2. Well, 4 to the 1/2 is the square root of 4. I guess technically square root of 4 to the first, but we don't have to write to the first power. All right, let's keep going. Square root of 16 is 4. 4 cubed is 64. Now 2 squared down here is 4, so you get minus 1/4 in the middle. And then finally at the end, you get plus 5 times the square root of 4. Square root of 4 is 2, so that's going to be a plus 10. All right, I'm going to kind of work up a little bit here. 64 and 10 is 74, and I'm going to subtract a 4th from that. If I make a common denominator by multiplying by 4 on the top and bottom, let's see, 74 times 4, times, is 296. So 296 minus 1 is 295 fourths. That's the final answer as a fraction. And I realize that's probably the most complicated one, but let's double check it. Let's see if that really is 295 fourths. Ready? 16 to the 3/2 power minus 2 to the -2nd. Calculator's pretty smart. It's going to know how to do all this. Plus 5 times parentheses 4 to the 1/2 power. All right, fingers crossed we did this correctly here, people. Hit enter. I don't know, is that really 295 over 4? If I hit math frac, sure is. Look at us go. All right, so when I see you in class next time, all we're going to do is really practice with these exponent rules and start to hopefully become very confident working back and forth between positive exponents, negative exponents, radical and fractional exponent form. It's all really important to be able to evaluate within these exponented terms quickly and efficiently. So if you have any questions, let me know, but I'll see you in class next time.